But anyway, let's see what happens here. So sublimation, if you look at this, you can't go straight from a solid to a gas without passing through the liquid phase. With this part, you can't. But with this one, it allows it. Because down here, there's no liquid phase in this part of the diagram. Now, every substance has its own phase diagram. This is just for water. So if you look at methane or isopropyl alcohol or something else, it's going to look different than this based on the substance. But you have to know a few things. You have to know what these lines mean. And you have to understand what triple point means. Triple point is just where all three of these phases can exist at the same temperature and pressure. So at this temperature and this pressure, ice, water, and gas can all form at the same time. They can all three be present. Okay? That's what a triple point is. Critical point is where the gas and liquid basically are coexisting at the same time as well, but at a very high unstable ionized temperature. Okay? Does that make sense? Okay. Now let's talk about atmospheric pressure. Atmospheric pressure is all the air, the atmosphere, on top of you. Whenever you say I have the weight of the world on my shoulders, you are not kidding. You do. You do have the weight of the world on your shoulders because all the atmosphere is sitting on you. I mean, speaking of my mother, she was 5'9" when I was in high school. She's a big woman. I'm not like in heavy, but she's just a big, muscular, thick woman, 5'9", scared the bejeebers out of me growing up. Now she's 5'3", and kind of a slight little lady. She's lost 6 inches due to, 1, gravity, and then 2, you get the little cushions in your spine. They wear away over time, and you get bone on bone, so you start losing the cushioning between your vertebrae. So you do get shorter that way, but gravity takes its toll. I mean, astronauts come back about 1 inch taller when they're in space because there's no gravity pulling down them. Their little vertebrae can just kind of go apart. But we're being pushed down every day by atmospheric pressure and gravity because all this air, which we now know has mass, is sitting on top of us. And we're close to sea level, so we've got a lot of it sitting on top of us. Okay? Atmospheric pressure is all that air, the pressure of the air on top of us. So at 1 atmosphere, at sea level, we say there's 1 atmosphere of pressure, which means there's about 10,000 kilograms of air pressure on us, constantly. But we are pressurized creatures. And because of that, it doesn't crush us like a splat. Because we're also pressurized. We also have bones that are pressurized. And we can resist that strong pressure. A barometer is an instrument used to measure atmospheric pressure. Okay? So barometers are used to measure atmospheric pressure. We have typically